Welcome back. Welcome back to the course Responsible and Safe AI. This is the last week of the class. Hope you're still enjoying the course, and I can see some of you getting very tensed, worried about the final exam. I think if you've done the set of assignments in the course, weekly assignments, well and understood the content, I think it should be okay. So the general pattern is that we'll take some questions that are directly from the assignment, some questions that are so to say applied enough, and some questions generally to test whether you understood the concepts slightly to apply them also is what we would actually do for the final exam. So what I thought we'll do now is to just take a look at what all we have covered as part of this class and summarize the whole class. How did we start? Where did we start? And actually, during the semester itself, during the course itself, we've actually seen a lot of changes in, right? We started somewhere here for the course. And if you see, as the time progresses, there are things that have happened in the real world also. It'll be interesting for us to also look at them, right? For example, the new models that have been released, right, which will be interesting to see what happened with the content that we have seen as part of this course also. First few slides are from the intro to the course, and I've kind of put it in the order in which we saw the content, so you should be able to appreciate that how did we progress in the class, how we actually looked at the different types of content, and also make some connections to the understanding that you have as part of this course itself. So this is just to show that, look, AI is everywhere, and there's a lot of bias that because of these technologies that have penetrated to different domains, particularly in this case in terms of judiciary, in terms of crimes, in terms of policing, examples to show that these biases in the system can actually affect real world very heavily. So our goal for the course was this, right? Students will recognize possible harms that can be caused by modern AI capabilities. Students will learn to reason about various perspectives on the trajectory of AI development and proliferation. Students will learn about latest agenda items towards making AI systems safer. So if you look at all the content that we delivered as part of this course, we were keeping these goals in mind, which is recognize possible harms, learn reasons about various perspectives, and about latest research agenda. We tried to sort of say give you an understanding of all these three topics, all these three sort of say post conditions in all the content that we generated. And every course is supposed to be doing like that only, right? You want the course to be aligned with certain goals. These were our goals. What we said we will cover, this is from the intro video content, AI capabilities, AI risks, robustness, interpretability, inconsistency, transparency, alignment, privacy, fairness, bias, domains, and about some panel discussion, some paper reading, going into details of a particular paper. All that is what we initially had planned for. I think we've done a decently good job. We have attempted almost all of this. In this RAI domains, we kind of did only the legal, which is okay, which covered the understanding of how responsible in AI is done in the legal domain, but there are also other domains that one can think of. Except for that difference, I think we did a fairly good job in trying to cover all the topics that we said we will cover. Improvements in AI capabilities with the ChatGPT 3.5 is what we started off with the class, but now I think we're talking about like 0.1, right? I'm sure some of you have already played around with it, or if you've not played around with it, please do go get access to it or read about it. I think you'll be amazed how much it has actually made progress from the time we started the course until now. I think I put the we need to get a quick view of it. Just go to OpenAI's YouTube channel. I think the last 10 videos or 12 videos that they have uploaded, just take a look at them. They're all short 2 minutes or 3 minutes video. Take a look at them. You'll get a sense of what are the kinds of problems that they have actually addressed in the new model. So what is the current situation at that point in time when the semester started? I think most of this is still valid. Hard to differentiate between AI, human. You should probably look at some of the recent works on this also, is to differentiate. So for example, one of the recent works is to differentiate AI versus human generated content for Hindi. How did we get here? Scaling up. So what changed in terms of what has made the AI becoming more and more influential is probably some of these things. Scaling up algorithms, scaling up data for training, increasing computing capabilities, all that. Not many predicted that we'll be here. Big worry was AI overtaking human beings, which I think is still a worry. There's lots of discussion around the topic of existential risks and the alignment question and the AGI topic. All of that is still very, very active question, even both in terms of research and in terms of implementation. Some examples of at least Google search I just showed you that AI capabilities, what all it talks about. I'm sure if you do the same thing now, you'll get something relevant right now, whatever is happening. Then we started looking at technical content. AI capabilities is the first topic that we saw, where we spent a lot of time in looking at different types of capabilities, vision, RL, language, multi-paradigms. So in terms of actually making choices in a game, making heuristics, all of that is what we saw. I'll show you some. So the way I built the slides were just take the copy of the content that we used in the class during the semester, and then used only some parts of it. And I don't want to go through all the so to say 11 and a half weeks into whatever the number of slides today as part of the summary. I just did this some random selection of topics from the end to give you a sense of what all we have covered. Right, we start off with saying that, look, in 10 years before, the algorithms for finding the numbers, face recognition, object detection, all of them are very, very primitive. As time progressed from 2014 till 2019, things got better and better, and that's what this article talks about. In 2022, things got very, very good, where we were able to actually, for a prompt, the images that they were generating was very, very apt, correct, and with less of errors. But more recently, things have changed even better, from parameters of 350 million to 20 billion. The images that we are producing are fantastic in terms of the prompt that is given and the images that we get. Right, same topic, same idea, continuing in this slide also. I did this, probably I should try and do this again, responsible and safe AI class that first when I wanted to teach, I posted on one of these vision models and asked it for generating an image, and this is what it generated. From image generation, we went to video generation, and video generation also was very primitive at some point in time, and then we have gotten very good at doing the video generation over years also. Right, so if you see here again, some of these videos are very, very good, very close to what we would have expected in the real world. And of course, some of these are also examples of video generation, which are very realistic. Not only images, not only videos, there's also a lot of progress that has been done on the text side. So if you look at topics that we saw, text generation, common sense question answering, planning and strategic thinking. So if you look at initial models, again, 13 years or before, The initial models are very primitive, not able to actually frame sort of say good sentences, grammatically correct sentences, all that. Over a period of time, we have gotten very, very good. I'm sure you're all using ChatGPT for writing emails, for generating code, all of that, which it's doing very well right now. Then we talked a little bit about common sense question answering and the strategic and planning kind of activities also by these models. It's also necessary, right? For example, this one is explaining a joke. Then math problems we saw a bit. Then these models have been used for in biology, in geometry, all of these areas where language models have been very, very effective in the recent times. So this graph, I think this graph will come back again in terms of the recent O1 performance also. But this is basically an exam for different topics to show how these models are performing in terms of comparing these models, how well they are performing, which is ChatGPT 3.5, 4 and 4 with no vision models, no image capabilities. So this is the video, this is the channel that I mentioned earlier about. Just go take a look at all of these videos. You will understand at least how they tried solving some of these specific problems. We looked at this strategic, which is a chatbot saying that, look, I want to find a home for this particular cost, this particular number of bedrooms, all that. How does the model take this information and then build on it by asking questions to you and all that. So O1, if you look at it, the biggest one of the biggest changes that they're claiming for O1 is that until now, ChatGPT, if you see, when you ask a question or a prompt or something, it kind of produces results immediately. So that's always been the way that they've been doing it. Now what they're saying is that, look, you can give a question to us, ask us to do something, and then the model can come back after 3 days to you. For example, think of a problem, do some experiment, collect some data, run these analysis, and write a report on it. Right? That cannot happen in the, so to say, in the pre-O1 models, right? Which is because they're always trying to find results immediately. You cannot, at least in the user interface that was publicly available, we could not do that. Now they're saying that, look, you can actually give us something which can take some n days. We'll come back and produce the results for you. And in these 3 days, it will also tell you what stage, what it is doing. Collecting the data, setting up the experiment, doing the analysis, writing the report, all that. Probably even at the lower level it can go. This one, I think there's a lot more from the time we saw this in the course and now, if you see, there's a lot more work on this topic of agents, which is companies are developing these agents. So many of the work can be just done with agents interacting with agents itself. There's no need for any human intervention. One specific intent for me to show this at that point in time was the timeline for the models to be trained. In this case, it was Jan 2022. And then I did this. So wherever I've kept some new slide, I've made this annotation, so you'll be able to see. I put this only recently, and then it says that as of my last update. So you really don't know what that last update could be. This could be 2022 itself. One should test some things after 2022 or just recent information and see how well it works. It also added this kind of information, which is if you're looking for the most current information or a recent change in the leadership, I can check that for you. Would you like me to? Right? I mean, I think these are the, this is why I get super excited about teaching some of these courses, is because as we do some of the courses inside a classroom or on these online platforms, things change very quickly in the real world also, which is so fun. Yeah, so this I do very often now. I use ChatGPT very regularly to get things that I want in terms of email drafting, in terms of some information, all that. Make it shorter. So I asked it to create something. It created a big one, and then I created slow. I particularly use it for social media posts. So some of my posts, if you see, will have some words, or particularly I use it for emojis, some interesting emojis that it produces. I like it, so I end up actually using it in my post also. Refactoring code, we saw this in terms of guardrails, jailbreaking. Then we saw about can actually give some prompts and it'll actually create code for you, right? In this case, it is actually creating code for playing a game. The math one that I said, then these in biology, gene sequencing, all those kind of topics also I've started using AI. And this article talks about 6 ways by which AI has actually influenced the vision models and topics like that. This one graph has been used many places. I think I've seen this graph in many places in the last semester, during the timeline for this course itself, where others have used this slide, right? It's very useful slide to say that how these models have become better in terms of capabilities compared to human capabilities, right? If you keep human capabilities as here, how well they're performing in some of the tasks. Tasks being handwritten recognition, speech recognition, image recognition, reading comprehension, and language understanding. I mean, there's also a big argument that there's a long way to go. I mean, there's no denial for that. This slide I also added to show you that at this point we started talking about some of these biases, which is in this case we are talking about Llama 3, particularly in the WhatsApp implementation. I asked for image of a doctor, I got this, nurse, and this was for the driving a car. And of course, if I ask you to understand what's going on, you will have some interpretation of that. Then Google Translate. So this one is Llama 3, this one is Google Translate. My friend is a doctor. You can replace this with many words: engineer, judge, and test what goes on. In this case, at least it says Mera. And then when you change it to nurse, it says Mary. That is Google. And now if you look at ChatGPT, the same kind of thing, which is there is a male, therefore there is a reference to dentistry. And if that changes to female, there is some nursing. Right. Again, these are fundamental problems in these models. It's not even clear. Let's take if we remove these bias completely from the models, how well the models are going to be useful in the real world. Right? I think we need all these answers. I'm also keen on answering some of these questions from a non-technical point of view also, right? I mean, social scientists, psychologists, behavioral scientists, what do they think about these questions? How are they interpreting these questions? What studies needs to be done to answer these questions? It's all very exciting for me, at least right now. And then we moved on to look at what is the world talking about these kind of bias, these kind of risks. So all of this we saw as part of AI risk section. So this is a large group signed this, saying that, look, I think we need to talk about mitigating AI risk as equivalent to nuclear risks and pandemics, particularly at a societal scale. White House produced some office order, which basically said that, look, if you're doing anything big, building foundation models, you need to let us know. Then we started looking at this face recognition. I think you did this as an activity, looking at this idea of face recognition systems failing to recognize non-white face. These models have also gotten into building weapons, which can be used in war, which has been highly controversial also. Some of these algorithms actually make a lot of mistakes. These mistakes are sometimes also deadly because it can actually cause accidents. For example, Waymo's car making an error, Tesla car making an error, causing an accident, all of that. Tesla's error. And then there is also errors in robots that are used in industry. It has to identify vegetable boxes to move places, but when it actually got a human being, it misidentified it as a vegetable box and tried moving and actually hurt him. This video, I'm guessing you would have seen it, to see how driverless cars make choices and how it is, sometimes it's actually funny, but it also misses the point of this police is coming and, so to say, seeing what the car is all up to. Gemini was in news for some errors that they had done in the models, basically trying to be very diverse in terms of the results. They ended up being so missing even very specific questions. That's what ended up happening. We saw that in detail. So it's a new slide, which is bias even a technology problem? If you remove bias from the models, how useful the model will be? I think these are good questions for you also to think about, given that now you understand to some extent the AI topics, you also understand some of the risks, right? So what is the space, right? And how, I mean, if you're a technology, if you are an engineering student, how are you thinking about the problem? If you are a non-engineering student and if you have some views, I think it'll be super nice if you can share this on mailing list also. What do you think? If you remove the bias from the models, what will happen? And is it even a technology problem? We continued on the risks with AI solutions. The malicious use of these AI solutions can be in bioterrorism. AI race is there. Countries are figuring out whether they want to have the biggest foundational model, largest foundational model, quickest foundational model, all that. And there's a belief that when you crack this problem of having a good model, that may help the country to have more superpower in terms of these topics. So if you look at the organizational risks, the defenses are actually built from classical security domain, which is build transparency, anomaly reduction, cyber defense, red teaming, and safety culture, right? So this is to some extent making users understand what the problems are. If you build it in this way, there's very less likely that some issues may happen inside your organization, right? The Swiss cheese model, if you look at it, there are different levels. So one can go through this, but it can't go through later. This comes here, this comes still here, but still it can't go through because there is transparency solution built. This one is a classical example that I keep repeatedly using about AI solutions or technology that are built for something and ends up doing something else. We started looking specifically about how to how to operationalize the risks in terms of these topics called vulnerability, hazard exposure, and hazard itself. And we saw some examples also how in different contexts how it is measured. I think as part of the assignments also we asked you some questions around this. Yeah, so the question that many people are asking is AI could someday reach human intelligence. When would that be? How long would it take? What will it take for us also to get there? Then we moved on to this idea called robustness, which is modeled to maintain the performance when faced with uncertainties. You want to do some adversarial attacks on the models to make sure that the models are doing what it is supposed to be doing. Right? Models should generalize well and provide reliable predictions, handling noisy data, distribution shift, and adversarial conditions. So we saw quite in detail what distribution shifts are. We saw quite in detail what the adversarial attacks are as part of this section of this course. Right, distribution shift, black swans, methods to deal with distribution shift and black swans. Right? Black swans is basically an event that is rare to occur, but when it occurs, it has actually a lot of implications. Right? Even that are outliers, lying outside typical expectation, and often carry extreme impact. That's what a black swan is. Many examples of black swans, for example, while in the signal, even though it is green, there's an ambulance that is crossing in the roads. How does, let's take an autonomous car, make a choice? Given that the signal is green, should I just move on, or given that there is a ambulance on the road, should I change my decision? The horse on a road, all that. Long tail distribution it shows up in almost every part of our life, I guess. Performance in a class, your likes of your Insta post, many of them will actually have a long tail distribution. And long tail distribution is meaning you can also think of it in connecting to 80-20 principle, which is to say that 80% of the let's take a content on the internet is generated by 20% of the people. Right? So which could be, say, this much, 80%, let's take this graph is x-axis is the users, y-axis is the content that are generated on the internet, so it will be something like that. Long tails is all over the place. Almost all examples, very rarely you're going to have examples where it is not a long tail. Then we spent some time on this understanding of known knowns, unknown knowns, known unknowns, and unknown unknowns to make an argument that it's going to be very hard to study something in this quadrant, which is things we are not aware of. We don't know what we don't know, unknown risks. It's going to be very hard in this phase, whereas in all the other three, there is some ways of actually understanding what is going on. As part of robustness itself, we started seeing a lot more details about different methods that are available, starting from ImageNet, different data sets and different metrics of studying the robustness also. This is ImageNet C, and then looking at experiments, then ImageNet R in terms of, so this one is corruptions in the images, this one is rendition, which is the images are not, so to say, something like painting, right? If you have that, things may change. ImageNet is, which of these images contains at least one of this is how the ImageNet dataset was created. Right, in this case, if you see rendition is because strawberry is used here as a earring, right, as probably a paper origami types, all of that. some drawing. These are very different, right? These are not just real images of strawberries or pictures of strawberries. Probably sometimes pillows, I guess, right? So the reason why we saw this is that your model should be able to also try and analyze, make sure that they analyze strawberries even when presented in this ways, not necessarily only strawberries as in strawberries itself, or pictures of strawberries itself. So we continued on this topic to study that how adversarial examples, adversarial testing can be done for these models. Right, ImageNet A is the adversarial one. We talked about some of these models, how it is detecting, given a mushroom, it's actually detecting it as pretzel and things like that. Can you actually make sure that the models are tested against these images is the data sets that we talked about. Right, ObjectNet, right, again, different sets of images showing chair itself in different forms, chairs, all that, right. Then we moved on to text to show that is an adversarial thing, not only in the images, but we should actually do it in the text also. So it is adversarial natural language inference, ANLI data set. Again, same type of questions, which is, can the models look at these adversarial inputs and not have an effect on their efficiency, not have an effect on the performance of the models, right? We spent a good amount of a time in understanding how these data sets could be created, or particularly in this case, ANLI construction process we went through, which is somebody setting a hypothesis, making sure that that is checked, verified, all that. We spent some time on also looking at different models. These are from research papers to see how these models perform against these robustness attacks. Methods also, we saw a few methods, right? Mix-up is simple one. Then we saw auto-augment. You may remember different ways of actually augmentations that you can do, right? Equalize, rotate, solarize, posterize, right? All of these ways by which the image can be actually modified. And the models need to be robust enough so that still it is able to actually predict what it is supposed to be predicted. Then we spent some time on distribution shift. Multiple types of distribution shift, covariate shift is something that we saw, and we went on to look at different ways of actually studying this distribution shift and how it affects the models also.